have a left hand and we have a right hand, and you ask me, right, imagine you have a neurological condition in an Oliver Sacks sort of an idiom, and somebody's only aware of one side of their body, and they say, oh my God, I'm deformed, I'm asymmetric, right? But we actually have a symmetry between the two things that can't see each other. Then we would still have a chiral world, but the chirality wouldn't be fundamental. There'd be something else keeping the fermions light. And that would be the absence of the cross terms. Now, if you look at what happens in our replacement for the Einstein field equations, the term that would counterbalance the scalar curvature, if you put these equations on a sphere, they wouldn't be satisfied if the t term had a zero expectation value, because there would be non-trivial scalar curvature in the swervature terms, but there'd be nothing to counterbalance it. So it's fundamentally the scalar curvature that would coax the VEV on the augmented torsion out of the vacuum to have a non-zero level. And if you pumped up that sphere and it smeared out the curvature, which you can't get rid of because of topological considerations, so let's say from Chern-Weil theory, you would have a very diffuse, very small term. And that term would be the term that was playing the role of the cosmological constant. So in a large universe, you'd have a curvature that was spread out, and things would be very light, and things would get very dark due to the absence of curvature linking the sectors. And that turns out to be exactly our complex. So in other words, just to recap, starting with nothing other than a 4-manifold, we built a bundle U. The bundle U had no metric, but it almost had a metric. It had a metric up to a connection. There was another bundle on top of that bundle called the chimeric bundle. The chimeric bundle had an intrinsic metric. We built our spinners on that. We restricted ourselves to those spinners. We moved most of our attention to the emergent metric on U14, which gave us a map between the chimeric bundle and the tangent bundle of U14. We built a toolkit allowing us to choose symmetric field content, to define equations of motion on the cotangent space of that field content, to form a homogeneous vector bundle with the fermions, to come up with unifications of the Einstein field equations, Yang-Mills equations, and Dirac equations. We then broke those things apart under decomposition, pulling things back from U14, and we found a 3-generation model where nothing has been put in by hand, and we have a 10-dimensional normal component, which looks like the spin 10 theory. I can tell you where there are problems in this story. I can tell you that when we move from Euclidean metric to Minkowski metric, we seem to be off by a sign somewhere, or I could be mistaken. I could tell you that the propagation in 14 dimensions has to be worked out so that we would be fooled into thinking we were in a 4-dimensional world. There are lots of things to ask about this theory. But I find it remarkable that tying our hands, we find ourselves with new equations, unifications, and 3 generations in a way that seems surprisingly rich, certainly unexpected, and I think I'll stop there. Thank you very much for your time.